Hello scientific brilliant people, how are you today? So today I'm going to give you a very important update on the magnifying power and magnification of the simple microscope. Simple microscope is also called a magnifying glass or a single convex lens, and please continue watching this video till the end to get a better understanding. So here we have a very small object whose height is HO, kept at a distance 25 centimeters from human eye. This distance is called least distance of distinct vision. So if you bring this object even more closer, you won't be able to see this object very clearly. And you can consider this object to be a grain of wheat grain, very small in height. Now it subtends an angle theta 0 on the human eye. Now you want to see this grain in a enhanced way. So we use a simple microscope or a single convex lens, and we keep this object between F and O such that we get the magnified image. We know that when any object is kept between F and O, we get highly enlarged and virtual image. So this is height HO and this is the height of the image. So when we see from here, our eye is very near to the lens. We don't see this, we see this. So this object, now you are seeing it in a bigger way. This is not a ray diagram, people. You are supposed to pass a line from the head of the image to the head of the object and to the eye or to the lens, one and the same thing. So this image is subtending an angle theta on the lens or the eye, and this angle was theta 0. So how many times this angle has become bigger, that is magnifying power, people. Whereas by how many times the height of the object is increasing, that is normal magnification. Both of them are totally different things, but under some circumstance, a particular situation, they both become equal. So here what do we have is, this object is kept at say distance u and we get an image at v. So hi upon ho is definitely v by u. With similar triangles you can prove that. But we do understand that if the object is brought closer, the image will also come closer to the lens or the eye. But you have to be very careful that if you bring this object at a particular distance called u minimum, the image will shift and it will come at a distance of 25 centimeters. If you decrease the distance by less than u minimum, then the image will fall nearer to your eye and the image distance will still decrease by 25 centimeters. And then under that situation you won't be able to see the image, because the criteria to see any object is the distance between the eye and the object or image should be at least 25 centimeters. So if you bring this object in this direction, and when the object comes at F, the image goes to infinity. But when you shift this object closer to the lens, the image will also come closer to the lens, and if this object distance becomes u minimum, the final image distance becomes d, 25 centimeters, and if you even decrease the distance by even a bit, then you won't be able to see the image clearly, because now the image distance from your eye or the lens is now less than 25 centimeters. So I have mentioned that this distance is u minimum and the image is formed at least distance of distinct vision, that is d. Right? Now since all these angles are very, very small, this was a wheat grain and it forms a very small angle, and even if you magnify it by 100 times, the angle remains smaller. So I can use small angle approximation, that is tan theta is equal to sin theta is equal to theta. So magnifying power is the angle subtended by the image upon angle subtended by the object at direct eye, theta upon theta 0. Since angles are small, I have considered tan theta and tan theta 0. From this triangle, tan theta is equal to hi upon d, mentioned over here, and tan theta 0 is equal to ho upon d. That is ho upon d. So dd getting cancelled, so I am getting hi upon ho. So here magnification means by how many times, I am talking about this magnification, by how many times the object becomes bigger in size. So the image height upon object height, that is this, and by how many times this angle becomes bigger, that is magnifying power. Both of them, they are totally different, but as you can see, magnifying power is equal to magnification, because hi upon ho is magnification, they become equal only when the final image is at D. So if this image would have been formed at say 30 centimeters, then these two will not be equal. So magnification and magnifying power, they both are only same under one situation, that is when final image through the simple microscope is at D. That's what I have mentioned it over here, people. Very important thing. So hopefully you have understood the explanation, people. If you have any doubts, please do comment in the comment section.